Well, let's explore the behavior of implicit relations, not functions, okay? These are not functions. Otherwise, we could solve for y and do this explicitly, not implicitly. So here we go. Let's kind of scan through here. And by the way, subtitle, worth reading. Implicit differentiation with the first and the second derivative test. And it is this lesson, and it's lots of fun. So we will need the first and second derivative tests. So if you scan through, is this relation increasing or decreasing? First derivative test, increasing, first derivative test, concave up or concave, second derivative test, concave up, second derivative. We're going to need the first derivative and the second derivative, so let's just jump right in. I'm going to go for a little rewrite that just sort of helps us wrap our mind around it. Skip this step if you want to. This is 1/4 x squared plus 1/9 y squared equals 1. And we will take the derivative with respect to x. I'm not showing all my work this time. So 1/4 x squared would be 1/2 x. The derivative of 1/9 y squared would be 2/9 y dy over dx. And that is equal to 1. We're going to solve this for dy dx. So dy over dx equals, well, we would subtract that. And then we would divide by that. And that is a mess. And I wrote it very sloppily, and I apologize, but that is 2/9. So let's clean this up because it's just gross looking. We can, well, first of all, it's negative, and it is a fraction, and it's x over y, but the fractions itself, the numbers 1/2 divided by 2/9 is really 1/2 times 9 over 2, so it's 9 over 4. There we go. That's what we have. That's what we're dealing with. So that is our first derivative. Now let's find our second derivative, because we're going to need it, right? So the second derivative, d squared y over dx squared, we've been through this notation before, is the derivative of that. And I hope you're thinking what I'm thinking. Pinky. It's from a cartoon in the 90s. Are you pondering what I'm pondering? Quotient rule. That's what I'm pondering. So let's put that negative with the numerator. It'll make it easier. So f prime g minus f, and then g prime, the derivative of 4y, would be 4 dy over dx, and all that divided by g squared. That's not a 9, that's a 4. Briefly forgot what I was doing. Okay, looking through my work. It's okay to pause, make sure you're good. Yep, we're good. All right, let's keep plugging things in and chugging along here. So negative 36y plus 36x times dy over dx, let's call it what it is. That'd be negative 9x over 4y. That's sloppy, but we'll keep going with it. Over 16y squared. Let's keep going. And you could stop here if you wanted to, but I'm just having so much fun. I can't contain myself. You can't see my face, but if you could, you would just think all the excitement here. Let me give you a brief representation of how I'm feeling right now. There you go. All right, moving right along. Negative 36y plus, oh, let's just write it. No, minus. No. Let's just write it with no explanation whatsoever. Minus 81x squared over y. Don't even ask, just write it. 16y squared. Now, the more we do, the more room for error there is. So if you wanted to stop about here, you could. I do want to keep going because, again, I'm having so much fun, I can't contain myself. But the earlier you stop, the less room for error there is in this. However, in just a minute, we're going to need to plug things in to this, or even this, but that one's iffy. And in doing so, we need to determine some signs. So that's going to be important. So that's why I'm simplifying as much as I am. And just because I feel like it, I'm going to keep going, actually, because this is more fun than I've had. Let's multiply every term by y, and that's going to wipe out this y in the denominator. So we'll have negative 36y squared minus 81x squared over 16y cubed. Every term got multiplied by y. And if you want to stop there, you can. There is a way to continue going with this. There is a way, and I'm trying to remember what it is. And the fact is that at some point we can just do some finagling and factoring and all kinds of fun stuff and end up with 1 in the numerator and some other numbers floating around. It's fun, but it's not worth our trouble right now. I almost went there, but let's not. Here we go. First derivative, second derivative. Is the graph of this relation increasing or decreasing in quadrant 4? Okay, well, quadrant 4. What's quadrant 4? Not what, but where. And you know these, I'm sure you do. But what's really important to know is the obvious, that in quadrant 1, x and y are positive. You know where this is going, right? Quadrant 2 is negative, positive. You don't have to write all this because you know it. Negative, negative. That one's like a sleepy, smiley face sort of thing. And that one's, well, not smiley, just sort of sleepy. There we go, positive, negative. So what I'm going to do is plug in not numbers, but just signs. You can do that. It's totally okay. So let's grab a pen. What color? Purple. That's a good suggestion. Thank you. Is the graph of this relation increasing or decreasing in quadrant 4? So what I'm going to have is, and this is in my head, not writing it down yet, negative 9 times positive over 4 times negative, and I wonder what the sign is. So let's start writing. Negative 9 times a positive. This is not mathematically written. And then 4 times a negative is going to give me a negative over a negative. That's really sloppily written. Let's use the words instead. Negative divided by negative, and that's going to give me a positive. So this is just my doodling. This can happen in my head, but this is increasing. Okay? You don't even need numbers now. We're just using signs. Is the graph of this relation increasing or decreasing in quadrant 2? Let's figure this out. So we have negative 9 times x, which is now negative. Negative 9 times a negative, you can see where this is going, divided by 4 times y, which is positive, so 4 times a positive, and that's going to give me a positive divided by a positive. Again, this is the head work. This is not the work you show when you're like demonstrating every little thing, but a lot of it can happen in your head. You end up with a positive, so this one is also increasing. I will abbreviate that word. Here we go. Is the graph of this relation concave up or concave down in quadrant 1? So we're going to plug in positives into the second derivative now. So what we're going to have is negative 36 times a positive squared. Well, we're going to get a positive from that and a negative from that. Minus 81, and again, this can be in your head, times a positive squared, all divided by 16 times a positive. And it is cubed. Well, the numerator is negative, because that's positive times negative. So negative minus another number. So we're going to have like super negative here. And then we're going to have a positive here. So we're going to get a negative. And therefore, this one is, I almost said decreasing. No, we're dealing with the second derivative. This is concavity. So this is concave down. Feel free to abbreviate that. I did not. The next one is this graph. You know where this is going. Let's make this quick. Quadrant 3, so negative, negative. So we're going to go negative 36 times negative squared minus 81 times negative squared over 16 times negative cubed. Okay. The negative cubed is negative times 16 makes it negative. I don't care about the number. I care about the sign. Squared makes it positive, but everybody else was negative, so negative 36 times positive minus 81 times positive is going to give me a negative. We still have a positive. So we are concave up. All right, you ever wonder what this graph looks like? Well, you can type it into Desmos, or you can use some pre-calculus skills. This is an obscure old pre-calculus topic. It is lovely. It is good to know. Very quickly, let me show you what this graph looks like. This, my friends, is an ellipse. It is a circle that got flattened. And 1, 2, 1, 2, 1, 2, 3, 1, 2, 3. And just real quick, like a lesson in 30 seconds. Here we go. I will move in the x direction the square root of 4 from the origin. We're at the origin because it's not shifted. Otherwise, it would be like x minus something or x plus something, and x minus or plus in the squared, in the parentheses with the squared. So back 2, forward 2. This is square root of 4. Don't panic if you don't know this right now. Square root of 9 is 3, so up 3, down 3, and we have an ellipse, I should say. Mine looks more like a circle. When I try to draw an ellipse, it looks kind of circle-ish. But basically, it is taller than it is wide, if I would have scaled this correctly. And you can really see what you need to see from here. The entire top part is concave down. The entire bottom part is concave up. Increasing, decreasing, and then decreasing and increasing. And everything you need is kind of in that picture, but this is the proof for it.